Hi everyone, I hope the writing is clear to you from the board. There's a question here, still under this multivariable calculus, double integration we are doing, finding the area under a plane, finding the area of objects between planes and on a flat surface, to say. So here we are asked to evaluate these double integrals, x y to the power of 2 dy dx, where d is triangle with vertices at 0, 0, 3, 1, and 0, 3. The first thing we do here is to sketch this triangle, because with just these figures we have here, they won't do us much good without sketching the triangle. So let's do a quick sketch of the triangle. You have your Cartesian coordinates, x, y, x. This is your y-axis. Because we have 3's here as maximum numbers, so I'll only graduate and stop at 3. 2, 3, 1, 2, 3. And of course, this is your origin 0. So the triangle has vertices at 0, 0. So there's a point here. 3, 1, y is 3 and x is 1. 3, 1, x is 3 and y is 1. X is 3, y is 1. This is y, x is 3, so another point here. And 0, 3, x is 0 and y is 3, so it's just here. So got these 3 points. You know, it's a triangle, isn't it? This way, this way. So we have a line that goes from here to here. We have another line that goes from here to here. We just label them A, B, C. And let's put 3, 0 here, 0, 0, and this is x is 3, no, x here is 3, y. So this is x, this should be 0, 3, I forgot here, sorry about that, 0, 3. I don't know whether the red mark is bright enough for you to see it. So this is the triangle we have. And because they say evaluate where D is the triangle with vertices at this point and this point, it means we are going to calculate this covered area here. This is what they want us to find. This area here is what they want us to find. Yeah? So more or less this triangle, instead of it being like this, which now it's going like this. Can you see that? Normally we know triangles, they stand this way. But now this one is slanted like this. Nevertheless, it's the same method we use. Okay, a problem like this, you can approach it from 2 different directions. In other words, you can solve it in 2 different ways. There's a simple way of doing it, in which case you interchange this dy dx. Instead of the x first, the y second, you do the y first and the x second. But then that will make you to have to do something with the limits of these integrals. Another method is, since we have 2 equations here, 2 lines to say, so you divide this triangle into 2 and you add up together. divide it into 2, and then sum it up together. So let's start with the first method, this second one, sorry. We'll divide the triangle into 2, and then we'll sum up together and find the integral of the whole triangle. So we have a line, this line here, that goes from A to C, and here we have A 0, 3, and at C here we have 3, 1. Let's find the equation of this line. Why do I need to find the equation of this line? Let me show you what I want to do. I want to start integrating with respect to x. So I'm doing the x. So in that case, I want x values of the limits. I'm looking for the limits of the x function. Y, the y, here I want numbers. 1, 2, 3, 4, 5, counting numbers. Yeah, for this outer one. This inner one, which is with respect to x, it could be numbers, it could be variables. But because we have equations here, I'm sure it's going to be mixture of numbers and variables. So I want to find the values of x of this line and the values of x of this other line. So if I cut this line here, this top line, this one, I cut it like here. And I also cut this one here, this bottom line, 0, C. This line here, 0 to C. Each 2, I cut it somewhere here so that I can find the value of x at this point. This one, so I can find the value of x at this point. Yeah? Or the value of x throughout the line, because any value of x on this line is going to be the same. It's just the value of y that changes. Well, first, let's find the equation of this line. We are just given a number here. Let's find the equation. You know, to find the equation of a line, you have y equals mx plus c, where m is the gradient of the line. What gradient means is the steepness. Like this one, you see, it's steep, you know, so the steepness. It can lie like this, it can go like this, it can even go like this. So that steepness is what we call gradient of a line. And then the C here is where this whole line cuts the y-axis. This number here, this is a constant, it's going to be a number. It's where it intersects the y-axis. So if that is the case, now you have y equals your mx plus c. If we are considering the line AC, where does it cut the y-axis? It's called the y-axis at y equals to 3. So now this already will have 3 here. But how do we find m? M, the gradient, is equals to increase in y all over increase in x. We normally say the rise over the run. So increase in y, the y value here is going to be 3 minus, it increases from 1 to 3 minus, and all over the rise is from 0 to 3 minus 3. So this one here we got 2 all over minus 3. That is m. So if we put it now here on this equation, you have y equals to minus 2 all over 3x plus 3. So that's the equation of this line. This line, that is its equation. This is the equation of that line. Yeah? But what I said earlier on is that I want the x value of this line, because I'm going to integrate with respect to x. So I want the x value of this line. So what do I do now? I will now have here y minus 3. This 3 comes here, and I will have minus 2 all over 3x. So now we have this 3 will now come here. 3 equals minus 2x. I want x. So I divide both sides by minus 2. here by minus 2. So now x is going to stay here. Yeah? But I don't want the minus sign to be outside. I want it inside. So what I do here, I will still have my 3 all over 2. Now I interchange, change position. Instead of y minus 3, I will now have 3 minus y. So for the line AC, x value is going to be 3 all over 2, 3 minus y. That's for the line AC. Okay? And for the line AC, this line AC, if we bring our integral here, let me write them here so that we don't miss out anything. The line AC is gonna be this line AC, yeah? If we consider the line AC first. So you have your y for this one. The y goes from where? For this line. The y goes from the y value. It goes from 0 to 3. The y value for this line. So it goes from 0 to 3. And then the x value, which I've just calculated here, for this line here, the x value here, it goes from 0 to 3 all over 2, 3 minus y. Right? For that line. And then you have your xy squared dx dy plus. Now let's consider the line BC. BC here. The line BC, let's find its equation again. We still have y equals mx plus c, and y is equals to mx plus, where does it cut the y-axis? It cuts the y-axis at 0, not 3. The one before was 3, this one at 0. So c is 0. So now we have here y equals mx. So let's find the gradient. Gradient m is equals to rise, which is the y, which is rise 1 minus 0 all over 3 minus 0, the x now. It's rise over the run. So 3 minus 0, which is 1/3. So m is 1/3. So if you bring 1/3 here, now this one is going to be y equals to 1/3 x. But as I told you, I want x, not y. So this is going to be now 3y equals x. So for BC, x is 3y. This was x and this is x. For the line BC, x is 3y. Yeah? So now, your y for this line BC, your y value goes from 0 to 1, and your x value goes again from 0 to 3y. And again you have x squared y dy dx dy. So the whole equation now is transformed to this integral form. This is what you get. This is what you get, yeah? So this is one of the methods. There's another method in which case I can just cut this triangle from top to bottom. I can, instead of cutting each line, I can use one line to cut both lines at the same time. Then in that case, that will make me to manipulate with this integral. Now this dy will now come first, the x will come last. I say I will do that method in another video. First, let's solve this one and see where it takes us. So once you reach this point, the problem is solved. All what we have done, this is algebra, this is not calculus. What we have done here, finding the line of finding the equation of the line, using the intercept, this is nothing to do with calculus. This is another topic, or another branch of mathematics, algebra. That's why before you go into calculus, first you do pre-calculus. So all those other topics you do before you enter calculus is preparation for calculus. Because when you enter calculus, you just use them. You just call them and use them. Yeah? What we'll be doing earlier on is not calculus. That is algebra. We're now going to do calculus now. Integrating this one. So I need to erase this. Don't need it. It's no longer required. Yeah? So if I just say this is I, let's give it an equation. We still have our I equals, we have this one here, which is 0 to 3. And we are going to integrate with respect to x because we have the x first. So if you integrate x here, what do you get? You get 1/2 x squared. So you get 1/2 x squared. The y is constant. We are integrating with respect to x. It has nothing to do with y. So our y squared is still there. Yeah? And still there. Plus our dy now. Okay? And then you have your limit, which is 0 to 3 all over 2 into 3 minus y. Now plus, again, you have this other one here, 0 to 1. Again, here we are integrating with respect to x. So we'll have 1/2 x squared, y squared, dy. Then you have your limit, 0 to 3y. Yeah? That's what we have done. We've done the first integration. Now, let's simplify these squares we have inside here. We don't need this anymore. Let's now simplify. This gives us, we still have this 0 to 3. Now, we put in this value here. Have x, wherever you see x, you put 3 all over 2, 3 minus y. That's our x. Squared it, then you have your y squared, have your dx, dy, sorry. Shall I just let's complete this one before we jump to the next one. Yeah, you have your 1/2 y squared. We are dealing with x now. So you have your x. So x now is 3 all over 2 into 3 minus y all squared. Yeah? And the other one minus 0, the bottom limit. But everything will go to 0. So let us just ignore these zeros we have at the bottom. Normally, minus this again, you will now have to say here 1/2 y squared into again. Now, your x this time is not this number, now it's 0. Right? Sorry, you have this number now raised to the power of this, your x now 0 now raised to the power of 2. So it doesn't make sense. Okay? You have your x, which is 0 raised to the power of this. It doesn't make sense. So let us just ignore that one and stay with this. Yeah? So minus, no minus again. We'll now have plus. You have 0 to 1. Again here, 1/2 y squared. And now your x here becomes 3y squared. The x now becomes 3y squared. dy, dy. What left is 0. We don't consider that one. Yeah? So this one here, this is what has problem now, because we need to expand. You have 1/2 y squared this is x. All this is the power of 2. You get let's expand this. If you have 3 all over 2, 3 minus y, then all squared. That's what we have now. First, you have 9 all over 2 minus 3y all over 2, all squared. This is what you have. So, if this is what you have, this is going to be problem like this. Let us just say 3 all over 2 again. This is algebra. So this is going to give us 9 minus 6y plus y squared. So now times 9 times, this is 9 times 9, this is going to be 81 all over 4. 9 times 6, 9 times 6, 54, yeah? All over 4 plus 9y squared all over 4. So this is what we got here. But you have again 1/2 outside. So this 1/2 now, this all this bottom gonna be 8, 8, 8, 8. So now you're gonna have 81 all over 8 y squared minus 54 y squared all over 8 plus 9 y cubed all over 8, because there's a y here. Yeah? No, we can even simplify this. Why have I done this? No, this is y, correct. There is y here, there is y squared here. Yeah. So this is 84, 81, y squared, I'm multiplying this, 4, this 2, get 8, plus, minus 54, y cubed, all over 8, plus 9, y to the power of 4, all over 8. This is what you get, and this is dy. And then you have your value here, 0, 3, plus this one here, a little bit simple, 1. So this is going to be y4 times y squared. This is 1/2 y to the 6 dy. Y to the 6 dy. So the problem simplified this way. Now we just got one more step to go of integration. Now we integrate this now, this time with respect to y. So if you integrate this with respect to y, this one here, this is y, you're going to have, first you have your 81 all over 8 times 1/3 y cubed, integrating this, minus, still you're going to have your 54 all over 8, so times 1/4 y to the power of 4, plus you'll have your 9 all over 8 times 1/5 now, 1/5. You are integrating as we go along, and then you have your 0, 3, plus this one here again, you have your 1/2 times 1/7 y to the power of 7. Integrate 0 to 1. Change the marker. Yeah. So now again, you come back. Wherever you see y, you put 3. So now this is going to be 81 all over 8 times 1/3 times, now this is going to be 3 raised to the power of 3, because it's 3 here, minus 54 all over 8 times 1/4 times 3 raised to the power of 4, plus 9 all over 8 times 1/5 times 3 raised to the power of 5, minus 0, because this bottom here is 0, so everything is 0. Yeah, plus this, plus now you start this again, 1/2 times 1/7, and whenever you see y, you put 1 raised to the power of 7 is just 1 here again, minus everything is 0 here. So what do you have? I want to take 3 raised to the 3 out, so I'll take 3 raised to the 3 out. This one now will remain 81 all over 24, minus, if I take 3 raised to the 3 out, so this one is going to be, I've taken there, so it's only 1 3 that is going to remain here at this top, 1 3. So 3 times 4 is 12, minus 1, 3 times 5 15, plus 1 16. Yeah, all over 8 times 2, 8 times 4 is 32, plus again 9 is going to remain here, so 9 times 9 81 all over 15. 8 times 5 is 14. That one is gone, and this one here, 1 all over 7, 1 all over 14, minus 1 all over 14. You get. So you just need to simplify this one, and then you get your final answer. I don't think I can go beyond this. I have calculator here, because this is need a calculator. Anyway, that's it. Thanks for watching. Yeah, bye.